Good morning, everybody. So, students, today, we'll start with a new chapter, states of matter, right? Okay. So, we'll do some sums in this because theory, though, I think you know, right? Theory, though, I think you're quite familiar, right? Fine. Now, students, in this, you have studied three states. One is gas, correct? Yes, liquid and solid, right? You have studied gas, liquid, and solid, but I think majority of the time, we'll concentrate on gas only, right? Many questions, you'll be doing on the gaseous state only. Fine. Liquid solid part is not that much. Fine. So we'll come to the gaseous state now. Correct. So students, the theory part I think you already done in the NCRT, right? So we'll not stress much on that. We will take up some problems, right? Now you know that you have done one equation. PV is equal to nRT. Am I right? This is the equation, right, for a gas. What is P? P is the pressure. Okay. Yes. Very good. Wait 1 minute. Yes, P is the pressure, right? Okay, fine. V is the volume. So you can have a relationship between these four actually. Pressure, volume, temperature, right? This is the temperature, right? And N is the number of moles. Okay. So what is N? Number of moles, right? Fine. Very important. Pressure, volume, temperature, number of moles, right? And very, very important, what is the value of R? R is called universal gas constant. Universal means this constant will never change. Always be as, you know, for all gases, this value is same. Whatever gas you take, this value is coming out to be how much? 8.314 joules per mole per Kelvin. So it has energy units, right? 8.314 joules per. Students, I want you to by heart this value. You can write this even in another way. 0.082 liter atmosphere mole raised to minus 1. Students, you can write this way also. 8.314 or you can write 0.082. But that will be in liter atmosphere, right? Okay. So this is the value of R. Very, very important. Okay. Liter atmosphere. Fine. Now, students, when you're doing sums, be very careful. Pressure, please concentrate. Very, very important, is expressed in atmosphere. Most of the time, you'll get pressure in atmosphere. They'll say 1 atmosphere, 2 atmosphere, like that. Okay. The usual pressure, what we call as NTP. NTP means normal temperature and pressure. Normal temperature and pressure, remember. Here, the normal temperature is 1 atmosphere. So, sometimes they'll call STP also. Please don't get confused. Both are same. Clear? Whether you say NTP or whether you say STP, right? Pressure is 1 atmosphere, normal pressure, right? Okay. Volume, students, expressed in liters. Very, very important. So always they will write in liters. Clear? Temperature, they'll write in Kelvin. Now, if it is given in Celsius, suppose I give 20 degrees Celsius, I think you all know this. You just add 273, you will get in Kelvin. It's very easy, right? So you will get 293 Kelvin, right? You just add 20 to that, right? 273. Okay. Get in Kelvin. The Kelvin, don't put that degree actually. Like, it's not required. You just write Kelvin, right? Is that clear? So you don't have to write degree, just put K there, right? So this is how you write temperature. Add 270 to that, right? Okay. Then N usual number of moles. So sometimes they'll give you grams. Now you know how to convert grams to moles. Grams divided by molecular mass will give you moles. Okay, fine. So you can find out that. And you know the value of R also. Most of the time students will use this value of R, 0.082. Fine. So use that value of R, right? And you can do sums on this. But some small things here. Suppose, they don't give pressure in atmosphere. Student is very careful. Sometimes they'll give you pressure in terms of centimeter of mercury. Okay. Now students, how is pressure measured? I don't know how many of you know this. Pressure is measured using an instrument called barometer. Yeah. Is that clear? So they have a special instrument, right? 1 minute. Give me 1 minute. Okay. So pressure, students, is done using barometer, right? Let's start now. Now, what is barometer? Barometer is actually filled with mercury. Though they fill it with mercury, right? Fine. So you have a lot of mercury here, right? Okay. Fine. Now, students, one end is closed, one end is open, open to the atmosphere. Is that clear? Let me show you with a different color. Open to the atmosphere, right? Okay. Now, students, the atmosphere will exert some pressure. Clear? Some pressure will come because of that. Now, one atmosphere is equal to, and they'll measure this difference in height. Whatever the difference in height comes, na? This is the difference in height, correct? Fine. So, because of the atmospheric pressure, it will come down. Now, this difference in height, normally for one atmosphere, it comes out to be 760 millimeters of mercury. How much? Or if you want to write in terms of centimeter, one atmosphere is 716 millimeters of mercury. Okay. You can write in terms of centimeter also. It will be 76 centimeter mercury. Fine. Yes. This is the normal pressure. So sometimes in exam they'll give you just centimeter of mercury. Don't bother. 76 means one atmosphere. This is how pressure is measured actually. Very easy instrument, right? You use for a lot of time. Every lab will have this, right? Close it and open, like this. Atmospheric pressure will come. Fine. This is a normal pressure at sea level. Fine. Now students, one more thing before we do sums. One atmosphere is equal to, please remember, if you want to convert this in terms of the SI unit of pressure, please by heart this. One atmosphere is 1.013, right? Correct? Into 10 to the power 5 Newton per meter square. Very important. 1.013, this much Newton per meter square. Fine. Sometimes they write in bar also. 1 bar is actually equal to 10 to the power 5 Newton per meter square. It's almost same only, 1 atmosphere, 1 bar, right? Not much difference is there. Clear? So suppose then you have to convert to SI unit. SI means you have done physics, right? You convert Newton per meter square. Fine? So these all things I expect to know about pressure. Then we come to volume. Volume, it's very simple. You just use a measuring cylinder, right? Measure the volume. Volume can be expressed in centimeter cube. Centimeter cube and ml both are same, students. Meter cube, liter, You can have volume in everything, right? So let me write now here 1 centimeter cube is equal to 1 ml. Both are same. Is that clear? Both are same. 1 meter cube is equal to 1 meter is 100, right? So 10 to the power 6. So 1 centimeter cube is same as 1 ml. Fine. Clear? 1 meter cube is 10 to the power 6 centimeter cube. Clear? 1 meter is 100, right? Okay. And 1 liter, very, very important, is the most commonly used, right? Is equal to 1000 centimeter cube or 1000 ml. This I think everybody knows, right? Okay. Students, please note down this very, very important things. Please note it down. So these are some of the important conversions, like, yeah. Please note it down. So when you are doing sums, you will make use of this, right? Clear? So you can have all these units. Please by heart it. Okay, students, fine. So now we can start doing sums. So if you know all this, we can start doing sums, right? Clear? Let me take the first question now. Okay. 1 minute. Let me take the first question. Suppose I ask you a question like this. Calculate the pressure. Let's take a day-to-day example, right? Calculate the pressure exerted by one LPG cylinder. Now you know that LPG cylinder is used for cooking purposes, right? By one LPG cylinder. Okay. Which contains now approximately, LPG cylinder will contain approximately 14 kilograms of butane. Okay, approximately. So it's a big LPG cylinder, right? 14 kilograms of butane. Fine. Assume that we are working at room temperature. So room temperature is how much? 25 degrees Celsius, right? I'll give the volume also. Let the volume be like, let us take 10 liters. Let's take 10 liters, right? Okay, let's take 15 liters. Okay, fine. Fine, student. This is what is given to you. So there's an LPG cylinder, right, which contains butane, all these things are given. Now, first thing, students, you remember the formula. The formula, once you remember the formula, you can do any question. So first, always you write the formula. Then you see what all things are unknown. Okay, what is the pressure you know? Just check it out. You don't know. Question mark, right? Volume you know, correct? 1 minute, sir. Just give 1 minute. Give me 1 minute. Okay. So pressure you know. Okay, sir. Just check it out. No. Yes. Sorry for that call. Call right. So pressure you don't know, students, right? We see this now. Volume you know. What is the volume? 15 liters, right? Yen. Yen you have to calculate. What is yen? Yen is the number of moles. Correct? Number of moles, right? Now, number of moles you can calculate if you know the mass in grams, right? Divide by molecular mass. Grams by molecular mass. Now you know the grams. Now remember I've given 14 kilograms of butane, 14 into 1000 you have to do. This will give in grams, right? 14 into 1000. 14 kilograms of butane, right? Okay. 14 into 1000. And butane molecular mass you can take it as C4H10. This is butane. Okay, butane, right? C4H10 is the formula. Now how will be the molecular mass? 48 plus 10 how much? 12 fours are 48, 58, right? Fine, student. This will give the number of moles. Fine. So once you know number of moles, now you know the value of R also. What is the value of R? Now students, you're writing pressure in atmosphere. I will mostly they'll ask in atmosphere only, right? So you will use the value of R as 0.082. Please remember, in this chapter, mostly you use this value only, 0.082 liter atmosphere. Temperature, students, you know, 25. Are you clear? 0.082, right? Temperature is 25 and you add 273 to that. Celsius, correct? You convert to Kelvin. Kelvin means how much will you add? 273, right? 273. So 273 plus 25 is how much? Tell me. 298. Fine. So temperature you got 290. Now you have to just substitute in this and get the answer. So it's a very easy sum. Okay. So take care of the units first. Very important. Okay. Moles you can do like this. Now you can just substitute and get the answer. Right. So what will be the answer? Tell me. This you have to do a calculation. Okay. So P will be equal to, and the final answer is shown that you will get in atmosphere. So P is equal to nRT by. Okay. You'll get the answer. Very clear? It's a very simple sum I gave you based on direct formula. Okay. So I think you can do this, right? Direct formula. Volume will get in liters. Yes, it's given in liters, right? So I hope you're getting it, right? Now, how they can make the sum complicated, you see. What they can do is they'll say pressure is constant, temperature is constant, right? Volume is changing, number of moles is changing. So V is proportional to N. So we can write V1 by V2 is equal to what? Is it okay? So they'll keep two things constant. Pressure, temperature constant. Volume is proportional number of moles. Temperature to number of moles constant. Pressure is inversely proportional to volume. Like that they can ask you. Clear? So such type of questions can also come. We'll do one question like that. Just Okay. Yes, we'll do one question. Suppose I say an open flask contains air. An open flask contains air at 27 degrees Celsius. Okay. To what temperature the gas should be heated? To what temperature, right? The gas should be heated, right? So that two-third of the gas, two-third gas or air, sorry, whatever you say, air, right? Okay. Two-third of the air escapes out or is expelled out. Expelled means escapes. This is the question, right? Expelled means it comes out, yes. Fine. This is the question. So how will you do this now? Just see. So there's an open flask, right, which contains air at how much? 27. Right. So you have to heat it. Two-third of the two-third of the gas air will come out. Okay. Now, students, you read this sum carefully and just see which is constant. Now, when you say an open flask, listen to this very carefully. When you say an open flask, it is open to the atmosphere. So obviously pressure is constant. Okay. Pressure is constant. The atmospheric pressure acting on it, right? Fine. Pressure is constant. Volume is obviously constant because you're using the same flask, right? So volume is also constant. Same flask. Friends, getting it? Open. Pressure is whenever it is open, pressure is constant. Volume obviously is constant. Same flask, right? Okay. Now what is changing is the amount is changing. You see, first you had air and then the amount is becoming two-thirds now. So amount is changing means what? Number of moles are changing. And temperature is also changing. So these two are changing. Number of moles and the temperature, these two are changing. Very, very important. R is obviously constant. Okay. Number of moles, temperature. So what is the relationship we'll use here? You know that PV is equal to nRT. Now only these two are changing, right? So can I say N1 RT1 is equal to what? N2, P1 N1 RT1 is equal to N2. Because P and V are constant, right? Yes. PV is constant. Okay. So you'll get N1 RT1 is equal to N2 R. So RR will get cancelled, right? So what is the relationship you'll get? N1 T1 is equal to N2 T2. Fine. Now you know T1. What is T1? 27 degrees Celsius. Correct. So 27 plus 273. Remember, you have to convert to Kelvin, because it's very important. Only you can do the sum. 27 plus 273 is how much? 300, right? So T2 only you don't know, students. They're asking to what temperature the gas should be heated. So T2 is not known. Okay. T1 you know 300. T2 you don't know. Again I repeat, N1, N2 is changing. Now what is two-third? Now this is very interesting, students. Two-third of the gas is expelled out. Two-third of the gas is expelled out. That means how much is remaining? One-third is remaining. Are you clear? Two-third comes out. So one-third is remaining. So I can say N2 is equal to, in fact I'll use a different color for this. N2 is equal to two-third gone. So how much is remaining? One-third, right? Okay, I'll use a black pen only, no problem. So N2 is equal to, students, one-third of N1. Very, very important. N2 is one-third of N1. Two-third gone. So what is remaining? 1/3 of N1. This is the main part in this sum. Once you know this, you can do it. Okay. So N2 is 1/3 of N1. So once you do that, what will you get now? Just see. Okay. Yes, 1/3 of N1. Right. Now use a relationship. This relationship you have to use. See. Now what is here? N2 by N1 is equal to, let me write N2 by N1 is equal to what? You will get T1 by T2. N2 T2 is equal to N1. Correct? Cross multiply, right? So N2 by N1 T1. Now what is N2 by N1? Take it on this side. You will get 1 by 3. Is it right? 1 by 3. What is T1? 300. 300, right? Now you want T2, right? T2 is what you want. T1 is 300. Clear? So T2 is equal to, is that clear? So N2 by N1 1 by 3, 300 by T2, right? Clear? You know T1 is 300. Yes. So you'll get 900, right? Okay. That's the final answer, 900. That means you have to heat up to 900 so that 1/3 remains, 2/3 is gone. So are you getting it? This is how you do some. So please copy this down, very important sum. Please copy fast. Very, very important sum. So students, I hope you understood this sum, right? Okay. So I hope we got it right. So let's take some other sums now. Suppose I say an LPG cylinder, right? Can withstand a maximum pressure of, there is a limit, for an LPG cylinder, right? Can withstand for a maximum pressure of how much, like maybe like, 20 atmosphere. That means pressure can't go beyond 20 atmosphere. Maximum it can take 20 atmosphere pressure, right? Okay. At what temperature the cylinder will burst? Suppose I ask you the question like this: at what temperature, right, the cylinder will burst? So there is a gas inside an LPG cylinder, right? And it can withstand maximum how much? 20 atmosphere. Okay. And I'll give you the initial pressure of the cylinder is. Initial pressure I'll give you. Initially it had some gas, no? So some gas was there, right? Okay. So initially it will have some pressure because of the gas, it will have some pressure, right? So let me take some initial pressure as maybe like 10 atmosphere. Let's not take 10. Okay, 10 atmosphere, right? Fine. And we'll take the initial temperature, room temperature will take 27 degrees Celsius. Which is nothing but if you add 273, it will become how much? Are you clear, students? This is the initial temperature. I'm sorry, initial temperature, right? 27 degree Celsius, right? 300 Kelvin. Okay. So I want to know when the cylinder will burst actually. See, suppose you have a cylinder, LPG cylinder, right? If suppose suddenly somebody puts a matchstick on that or somebody puts some cigarette on that matchstick, right? Cylinder will burst. Am I right? Why? Because the temperature becomes very high. See, when you put a matchstick, temperature will shoot up. And that high temperature, what will happen to pressure? Pressure will also become very high. Fine. Temperature is very high, pressure also, cylinder will burst, right? Okay, it can't withstand that much. Fine. That's what we are going to do in this sum. Suppose somebody puts a matchstick, the temperature, how much it becomes, and cylinder will burst. Fine. Initial pressure students, initial temperature So very simple, what you do is, the equation PV is equal to nRT. Okay, volume is constant, you are not changing this. The same cylinder, right? Number of moles, again you are not changing. What is changing is pressure and temperature. Pressure and temperature only they are changing. Fine. So we can say P1V is equal to nRT1. Right. Same thing. You can write P2V is equal to nRT2. Right. So what you can write is P1 by P2 is equal to, okay. V will get cancelled, right? Other things. P1 by P2 is equal to T1 by T2. Fine. Getting it? Now just substitute the values, no? So what will be the values? P1 is how much? 10. P1 is 10. P2 is 20. That means double, like. Right? So 10 by 20 is equal to T1, 300. Correct? You don't know T2. So what is T2? 600 Kelvin. You see, 600. T2 is 600. Clear? So at 600 students, it will burst. So at this temperature 600, the cylinder will burst. Are you clear? So still 600, nothing will happen. And double the temperature, 300, double 600 will burst. Are you getting it? Because cylinder can go maximum only up to 20 atmosphere, right? Okay, so just copy this fast. I hope you're getting it. Fine. So I hope you're getting to do all this sum. So what I want to tell you is that in these sums and all, like two things will be constant, right? The other two will change. Okay. So like that sums will come here. My last thing we'll do for today. Okay, students, then bye. So we'll continue this next time, right? You please keep doing these sums, like these sums are very, very, important, right? So please keep doing these sums. Fine. So we'll continue this next time. Okay, bye. Bye.